Okay, it's time for part 2 of Unit 3B. And we have to change 0.09 to scientific notation. Well, let's multiply by 1 in the form of 100 times 100 over 100. And this equals, and in the denominator we have 100, and if we multiply 100 times 0.09, then we'll move that decimal place to the right 2 places, and we have 9 over 100, which equals 9 over 10 to the second, which equals 9 times and 10 to the negative 2, because if we change the location of the base, if we move it up stairs when it's downstairs, then we have to change the sign on the exponent. And there's our scientific notation, and that corresponds to B. Oh boy, look at that. Let me write that negative 2. Good. So now, let's do number 8. 8. And 8 says the hard drive of a computer has a capacity of 12 gigabytes, and the prefix giga refers to 1 billion, which is 10 to the 9th, so we have to write this in scientific notation. Okay, 12 times 10 to the 9th, and this equals, now we can only have one digit to the left of the decimal, so that's going to be, I'm going to make this smaller by a factor of 10, make that 1.2 times 10 to the 9th, so I have to multiply this by a factor of 10 in order to do that. And notice, if we multiply 10 times 1.2, we'll have 12. And now we have 1.2 times 10, and since the bases are identical, we'll add the exponents, and the exponent here is 1. It's understood. And 1 plus 9 is 10, and we've got it. And that is C is the corresponding letter relative to that. Now, for number 9, it says the total amount of money spent each year on food by Americans. And by the way, that order of magnitude can be found on page 147. So let's say we've got 300 million, approximately 300 million, 10 to the 6th, people in the United States. All right. And let's say we're spending $10 per day per person. And so that's going to be day persons. When you invert and multiply, you'll get day persons. And now there are 365 days in the year. And so the days will divide out, the persons will divide out, and the only units we have left are dollars. So this is going to be approximately, and I'm going to round this 365 up to 400, because we just need an order of magnitude. So I'm going to make that 400. And so we've got 4 times 3 is 12. And we have, let's see, 1, 2, 3, 4, 4 zeros there. And another times 10 to the 6th. And now we have Oh, did I get that right? No, I didn't include this 0 here. So, excuse me. Let me make that 10 to the 6 times 10 is 10 to the 7th, isn't it? Okay, and so this equals 1, 2, let's see, O times 10 to the, 10 to the, I beg your pardon, to the 10th, and if I move this decimal over twice, this decimal here twice, I'll have 1, 2 times 10 to the, if I make this smaller by a factor of 100, I have to make this larger by a factor of 100, so that's going to be 10 to the 12th, which is approximately 1 trillion. Dollars. And we've been talking dollars all along. Maybe I better include that. So we just determined that it is C, $1 trillion. Good. Now let's do number 10. And it says the distance from the Earth to the Sun is 92,900,000 miles. How long would it take a rocket traveling at 2.9 times 10 to the 3rd miles per hour to reach the Sun? So we're doing 10, and we're talking about just simple division. So we have 9 to 900 miles divided by 2.9 times 10 to the 3rd miles per hour. And so this equals, in terms of scientific notation, that's going to equal 9.29 times 10 to the, I move this decimal over 3 and 3 more, 10 to the 7th, and divided by 2.9 times 10 to the 3rd, and this is when you invert and multiply, your units are going to be hours. And now 10 to the 3rd goes into 10 to the 7th, 10 to the 4th times, and 9.29 divided by 2.9, if we get out our calculator and compute that, we're going to get approximately 3.2, and as we said, that's 10 to the 4th hours, and that's D. Now let's go to 11. In fact, let's stop this and do a part 3.